Hi, I'm Veer Mahajan, and in this video I'm going to be talking about the easiest way to calculate the LCM and GCF of any amount of numbers, and that's the ladder method. So I'm going to start off with a pretty big example, 33, clear up some space here, 33 and 36, 33 and 36, and we draw a line here, and what's in common with them? Right away we can see that 3 is common. 3 is a multiple of 33 and 36. So 3 is a factor of 33 and 36. So we write a 3. And now we divide each of these numbers by 3 because we've written that there. Now what do we get? Well, we get an 11 and a 12. And now we can see that there's nothing in common between 11 and 12 except a 1. And we can write that, in fact, 1. But after that, it's just the same. It's 11 and 12 again and again. So we can just end it at 1. And now the GCF is 3 and 1. We multiply them. So 3 times 1 equals 3. So the GCF must be 3. And you can try this on another way if you want. You can use the getting all the factors and the common factors, then finding the largest one. You can do prime factorization, but basically you can try that, or you can maybe Google it or something. But that's the GCF. And now when you already have this much, you can immediately find the LCM. And what you have to do that, you multiply this and the last numbers that you have here. This is the most simplified form. And what we get here now is 3 times 11 times 12. And what is that? Well, that's 132, those two, times 3. And I'll quickly do this, 6, 9, 396, that's our answer, that's the LCM. So I'll just show you that this is in fact the correct one by using the prime factorization method, which is also pretty cool. If you don't know these, I may talk about them in a future video, but this is just a really quick way if you want to figure them out. And this 3 is already included in here, and you'll see what I mean in a second. And then 11 is prime. And now we can immediately find 33 here, 11 times one of those 3's. We can find 36, this one here times that one, that's 36. And 11 times one of those 3's, 33. And times 4, that's 400. Minus 1 times 4, which is 4. Minus 4, and we get 396. So that's a pretty cool way. And now I'll show you that this works with more than one number if you aren't convinced of that. And again, we can simplify them all. And what can we divide them by? Well, we can immediately see that these are all multiples of 3. 3, we write that there. Now after this we have 5, because 5 times 3 is 15. We have an 18. A 6. 6 times 3 is 18. And 20, and a 7. 7 times 3 is 21. And now we have 5, 6, 7. And we can't simplify those. Well, now we can do 1 again if you want. Then you'll still get 5, 6, 7. And so basically it just goes on. So we can end it at 1. So at 1 you're done. And now that we've reached here, we can again find the GCF, which is a 3 times 1. So GCF is a 3. And now the LCM, let's write that there, LCM is the 5 times 6 times 7. What is that? That's 30 times 3. I'm just doing this in my head. So okay, I'll show you. 5 times 6 times 7. This here is 30 times 7. And there's that 3 over there. So 3 times 30 times 7. And 30 times 3 is 90. This is 90 times 7. 9 times 7 is 63. And that's 90 times 7. So this becomes 630. The LCM is 630. Now let's do, if you aren't convinced of this and you think that might be wrong, you can do the prime factorization, and I'll just do the prime factorization. What were the numbers? They were 15, 18 and wait a minute. So 15, which is 3 times 5. There was an 18, there was a 21. This is 7 times 3. This is 3 squared times 2. So that's the same answer. You can go back in the video and find that. So anyway, I hope you learned something, and this will help you in the future when you're trying to figure out the LCM and GCF of other numbers. Thank you for watching. Bye.